sugar, liquid bleach, and baking soda. These are common household products. Each of these is a chemical compound. A compound is composed of two or more elements that are chemically bonded together. There are two types of bonds that hold atoms together: ionic and covalent. Table salt is an ionic compound. A salt molecule is composed of one sodium ion and one chlorine ion. An ionic bond is formed when an atom gains or loses one or more of its valence electrons to reach a stable energy level. Ionic bonds are formed between metals and nonmetals. Sodium is an alkali metal and has a single valence electron. This electron orbits in the outermost electron shell. The shell needs to lose one electron or gain 7 more to reach a stable electron configuration of 8 electrons, according to the octet rule. Losing one electron requires less energy than gaining 7, so sodium forms compounds by giving up this single electron. An atom of chlorine has 7 valence electrons. In this case, the outer shell needs to gain 1 electron or lose 7 to reach a stable configuration. Since gaining 1 electron requires less energy than losing 7, chlorine gains an electron when it forms compounds. An atom of chlorine has a high electron affinity, while sodium has a low ionization energy. As a result, chlorine takes sodium's single valence electron. The atoms of both elements thereby have complete outermost electron shells. This ionic bond forms a molecule of sodium chloride. Even though chlorine and sodium are highly reactive, because the ionic bond completes their outer shells, sodium chloride is stable. The ionic bonding results in ionization of the atoms. Recall that an electron has negative charge. By losing an electron, the sodium ion is positively charged. And by gaining an electron, the chlorine ion is negatively charged. Ionic compounds generally form crystalline solids with regular lattice structures because oppositely charged ions self-organize in a regular way to form giant ionic lattices. These compounds are typically solid at room temperature and have high boiling points. Furthermore, most ionic compounds do not conduct electricity as solids. Solid ionic compounds dissolve in polar solvents. For example, sodium chloride dissolves in water to produce positively charged sodium ions and negatively charged chloride ions. A covalent bond forms when two atoms share one or more electron pairs. Covalent bonds form between nonmetallic atoms. For example, a water molecule is formed by a covalent bond. It is composed of two atoms of hydrogen covalently bonded to one atom of oxygen. Hydrogen has one valence electron. It requires another electron to have the stable configuration of helium. Oxygen has 6 valence electrons. It requires 2 electrons to complete its outer electron shell according to the octet rule. When hydrogen reacts with oxygen, the hydrogen atom shares its 1 electron with the oxygen atom. Oxygen in turn shares one of its electrons with the hydrogen atom. The hydrogen atom now has a stable electron configuration. However, oxygen still needs 1 more electron to have 8 electrons in its outer shell. Therefore, it bonds with another hydrogen atom, again sharing electrons. The 2 atoms of hydrogen and 1 of oxygen form a covalently bonded stable molecule of water, with the chemical formula H2O. When 2 elements differ in electronegativity, electrons will be attracted to one atom more than the other. This results in a molecule that is more negative at one end and more positive at the other, with 2 poles. This type of molecule forms a polar covalent bond. For example, in the water molecule, oxygen's greater electronegativity attracts electrons more to its atom than the hydrogen atoms. Therefore, the oxygen part of the molecule has a partial negative charge, and the hydrogen parts of the molecule have partial positive charge. These partial charges account for some of the properties of polar covalent compounds. Most polar covalent molecules dissolve in water, have low boiling points, and are typically gaseous or liquid at room temperature. A nonpolar covalent bond is formed between 2 atoms that have the same electronegativity. As a result, the shared electrons are equally distributed between the atoms. Some diatomic molecules are nonpolar. These are molecules formed out of 2 atoms of the same element, such as hydrogen. Diatomic molecules of gaseous elements are common. Diatomic molecules of oxygen are part of the air we breathe. Nonpolar covalent bonds are also found in hydrocarbons. For example, a molecule of methane has 4 carbon-hydrogen single covalent bonds. The electrons are shared equally. Methane and other nonpolar covalent bonds are hydrophobic and do not dissolve in water. Covalent bonds are biologically significant. Covalent bonds form peptides, the building blocks of proteins. The bases of DNA, which make up the genetic code, are formed by covalent bonds. Without these chemical bonds, life as we know it would not exist.